Good morning, students. Class 9 Science Lesson Light. Let us start our class with a simple question. How do we see things? And the answer is presented to you all. We see because light is available. Can you think what kind of properties do light have that makes us see everything? So, in this class, we will be learning about the various properties of light that makes us to see everything. Reflection of light. When light falls on a shiny surface, it bounces back. This phenomenon is called reflection, and it is one of the most important properties of light that makes us see everything. So, in your junior classes, you already would have learned about the incident ray, reflected ray, angle of incidence, and angle of reflection. So, now we want to be learning about this in details and will be moving directly to the laws of reflection. There are two important laws of reflection, and they are the angle of incidence equals to the angle of reflection, and the second one is the incident ray, the reflected ray, and the normal are all lie in the same plane. Now tell me, have you ever observed yourself in a mirror when you start moving your hand? What happens when you move your left hand? Do you see the movement in the same side? No, right? The mirror image will be moving your left hand in the right side, and if you move your right hand, then the left side in the mirror will move. So now tell me, do you think the mirror is trying to play a tricks with you? Definitely not, right? So what happens? Have you ever thought of it? Okay, now I will tell you what exactly happens here. So, the phenomena where your left appears as the right and the right appears as left in a mirror, then it is referred as lateral inversion. The word lateral means side and lateral inversion means sidewise inversion. And you know that this lateral inversion which we observe is not caused by the mirror but the result of our perception. You can do one small activity to prove this lateral inversion. Write the word mirror on a piece of paper and keep in front of the mirror and observe it. What you will find, the word mirror is reflected as it is presented in the slide. And also try with the word like reverse and ambulance. Now tell me, have you ever looked yourself in a spoon while eating? Yes, you would have did. So what did you find? A curved image would have formed in the spoon, right? And so what I am trying to tell you is the mirror whose reflecting surface is curved in shape, then it can be called as curved mirror. And this curved mirror can be of many types like spherical mirror, parabolic mirror, etc. In a spherical mirror, the reflecting surface is curved inward, that is faces towards the center of the sphere. So such type of mirror is called concave mirror, and in mirror in which reflecting surface is curved outward, that type is called convex mirror. Now we will be learning about reflection of light at curved surface. But before that, we must know these terms which are very important to understand the concept of reflection of light. The first one is center of curvature. It is the center of the hollow sphere of which the spherical mirror forms a part. Second one, pole. It is the geometrical center of the spherical mirror. That means the middle of the spherical mirror. The third one is principal axis. It is the perpendicular line joining the pole and the center of the curvature of the mirror. For this, you can refer these images. You can find out the principal axis in the mirror. Fourth one is radius of curvature. It is the distance between the pole of the center and the curvature of the spherical mirror. And fifth one is principal focus. The point as the principal axis of the spherical mirror where the rays of light parallel to the principal axis meet. after the reflection from the spherical mirror. And the last one is the focal length. What is this? This is the distance between the pole and the principal focus. So, to understand this one, you must know all these 5 terms of the reflection of light. Next, we will learn the rules for the construction of image formed by the spherical mirrors. So, to find the position and nature of the image formed by a concave mirror, we need to know the following rules. And the first rule is a ray passing through the center of curvature is reflected back along its own path. This means that whenever a ray is passing through the center of curvature, that ray will be reflecting back in the same direction. The second one is a ray parallel to the principal axis passes through the principal focus after reflection. This means the ray which is parallel to the principal axis will be always passing to the principal focus after the reflection. Rule number 3. A ray passing through the focus gets reflected and travels parallel to the principal axis. This means that whenever a ray is passing through the focus will be reflected and will always travel parallel to the principal axis. Rule number 4. A ray incident at the pole of the mirror gets reflected along a path such that the angle of incidence is equal to the angle of reflection. This means whenever a ray strikes the pole at the mirror gets reflected along a path making the angle of incidence equal to the angle of reflection. Next we will see real image and virtual image. Real image. If light rays coming from an object meets after reflection, then the image formed will be real and inverted, and this image will be produced on a screen. But if light rays coming from an object do not meet but appear to meet when they produced backwards, then the image will be virtual and erect, and it cannot be produced on a screen. Till now, we have studied the rules for the formation of images on spherical mirrors. But if we want to know the position, size and nature of the image, whether the image is real or virtual, then we need to draw some ray diagrams. So let us draw the ray diagram in order to know that what type of image is formed when an object is placed on the principal axis of a concave mirror at different positions. So for the first case, that is when the object is far away, the rays of light reaching the concave mirror are parallel to each other. Then the position of the image will be at principal focus, and nature of the image will be real, inverted and highly diminished in size. That means it will be small in size. In case 2, when the object is beyond the center of curvature, then the position of the image will be between the principal focus F and the center of curvature C, and the nature of the image will be real, inverted and smaller than object. Case 3. When the object is at the center of curvature, then the position of the image will be at the center of curvature itself, and nature of the image will be real, inverted and same size as the object. Case 4. When the object is in between the center of curvature C and the principal focus F, then the position of the image will be beyond the center of the curvature, that is C, and the nature of the image will be real, inverted and magnified. Case 5. When the object is at the principal focus F, then the position of the image will be at infinity and no image will be captured on the screen. Case 6. When the object is in between the focus F and the pole P, then the position of the image will be behind the mirror and the nature of the image will be virtual, erect and magnified. We know that science is all about sign and symbol. So here in this chapter also we are following a set of sign conventions that is called Cartesian sign convention. So in this convention, the pole of the mirror is taken as the axis origin and the principal axis is taken as the x-axis of the coordinate system. Now we will see in what are the cases the sign is taken as positive and in what are the cases the sign is taken as negative. In this, the object is always placed on the left side of the mirror and all the distance are measured from the pole of the mirror. So whenever the distance measured in the direction of incident light, then the sign is taken as positive, and if the distance is measured in the opposite direction of the incident light, then the sign is taken as negative. All distance measured perpendicular to and above the perpendicular axis are considered to be positive, and all the distances measured perpendicular to and below the principal axis are considered to be negative. Thus, this is how we put sign convention for measurement of distances. Till now, we have studied about reflection of light, lateral inversion, spherical mirror, rules for construction of image, ray diagram, and sign convention. So, with this, we bind up the classes for today, and in next class we will see the later part of the chapter. So, thank you.